So let's talk about deflection of galvanometer. Okay, so if this is stationary, okay, this was an experiment done by Faraday, right? So we are saying if the solenoid is stationary, okay, and the bar magnet is also stationary, if both of them are stationary, there will be no current is induced. No current is induced. Therefore, no deflection of the needle. No deflection. The needle on the galvanometer. This is galvanometer. This one, galvanometer is detecting whether there is current or not. So the needle does not shift, does not deflect if there is no current induced. But if there is current induced, then the needle will deflect. So the reason a needle deflects is because there is a current induced, and this current is induced as a result of relative motion between the solenoid and the bar magnet. Right. So I'm saying, okay, now if it is stationary, and now this one now, if I change now and say it is now it is now pushed in, you push it in, you push in the magnet, so now it's no longer stationary. Then what will happen? The current will be induced. Current and EMF will be induced. Current and EMF will be induced. And when the current is induced, there will be deflection. There will be deflection of the needle in the galvanometer. The needle will deflect. The needle will deflect. Now, if you try to pull it out of the solenoid, still the current will be induced. The current is also induced. There will be induced current. The current will be induced. And the needle will deflect. The needle will deflect. Right. So, but if you put in the bar magnet here inside the solenoid such that it is stationary, the bar magnet is stationary inside, then it is held stationary inside the solenoid. So the solenoid is not moving and the magnet is not moving. Then there will be no current induced. So no current in this case. No current is induced and no deflection as a result. No deflection of the needle in the galvanometer. Deflection. Now, so current will always be induced if one of them is moving. If one of them is moving, okay? If there is a relative motion between the solenoid and the bar magnet. If there's a relative motion between them. Right. I want to talk about the direction in which the galvanometer will deflect. Okay. So to give you a simpler method of identifying the direction in which it will deflect. So here, in this case, you see the needle is facing up here like this, meaning it's not deflecting. Remember, if it is deflecting, it's either it deflects to the right or it deflects to the left. It moves from this direction to that direction there. Right. So now what happens now? If you make the magnet to approach, then the needle will also try to approach it. So it deflects to the what? To the right. In this case, it deflects the right. That's how you can know it. If it approaches, then it also approaches the needle, so that they're going in one direction, right? So right. So sorry. So now, if you pull the magnet away, if you pull the magnet away, if you pull it out like this, you pull out the magnet, then the galvanometer will also go away. Since the magnet is going away, even the needle will go away. So that's how you know the deflection, the direction of deflection of the needle of. So in this case, it deflects to the left. So away, it also goes away. Then approach, it also approaches. Yeah. So that's how the needle, the galvanometer deflects.